Hey guys, this is Mr. Sal. We're going to go ahead and do this problem right here, which was asked by a student, so I hope this helps everyone out in solving a system of equations with elimination. But these are set up a little bit differently, and we do see the distribution right there, so I would want to get rid of that first, and we'll just do that directly. So on this first one, we're going to distribute the 5 right there. So 5 groups of 6x would be 30x's. 5 groups of y is just a positive 5y there. And this is still going to equal negative 3. And the second equation, we're still distributing the 6 there, so this one's going to become 6x. 6 groups of 3 is positive 18, and this equals 3y. Now, the thing about this right now is that even though the x's are lined up, this top equation is a 5y, and the bottom one is 18 that's added to the x terms. And they're equal to either y or constant. So what we want to do here is we want these both in this format right here, specifically because it is standard form, at least for a linear equation. All right, so again, I'm going to keep this top one the same. It's going to be 30x plus 5y equals negative 3, and that's good. Now, the second equation, 6x plus 18 equals 3y, though, I've got to move that 3y over. I want it on the same side as the 6x, which also means, simultaneously, that I do not want the positive 18 there with the 6x. So I'm going to subtract 18 from both sides. And I'll do that one in purple. And the second calculation, the 3y, I want to zero that out as well because it's on the wrong side. Now, even though I'm putting the minus 3y in green under the 6x. They're not like terms, so I can't actually combine those. The 18s are going to cancel out, and so are the 3y's. So this gives me a new equation, 6x minus 3y equals negative 18. And I'll rewrite it under the 30x plus 5y equals negative 3. In fact, I'm going to put it over here just to give myself a little bit more space, all right? So what does this do for us? Well, it lines up the x terms together and the y terms, and the constants, which they're equal to, both of these are in standard form, which is ax plus by equals c. Well, the next thing we would need to do is make at least one of the coefficients not only the same, but opposites. Okay, so right now, and it doesn't matter which one you chose to eliminate, I would be looking at the x's, just because I know 30 is a multiple of 6, and it would be easy to make that an opposite of that 30x. So I'm going to keep that top equation. It's still the same. All right, so we still got 30x plus 5y equals negative 3. That's okay. But the bottom equation, I want to change this one, all right? I want to scale it up so that the coefficient of x is going to become a negative 30x. So again, I noticed that 30 is a multiple of 6, which is why it shows this. But what am I going to have to multiply that by? I'm going to have to multiply it by a negative 5. Okay, and I've got to distribute that not only to this one term, but to all 3. So 5 groups, negative 5 groups of 6x is the negative 30x, which we have in purple. And this is kind of transforming it. Negative 5 groups of negative 3y is positive 15y's. And this should equal negative 5 groups of negative 18, which comes out, I believe, to positive 90 right there. So this gives us a new equation right here, which now when we combine it with the red one, meaning we're going to add them together, which is why sometimes this is called the addition method, it's going to eliminate the x's right there. 30x's minus 30x's, that's going to zero out just like we planned. That's why we wanted the coefficients to be opposites. And then the y's, 5y plus 15y, positive 15y, would give us 20y's right there. Well, then we've got negative 3, right? This is going to equal negative 3 plus 90, which comes out to 87. And the last thing we'll do on this is just divide both sides by 20 to make the coefficient of y a 1. So we get 87/20ths on that. And I'll just keep the fraction on this. I think the decimal on this wouldn't be as pretty as the fraction, so I'll just keep it like this. So now that we found one of the y values, we can find one of the corresponding x values, and it doesn't matter which equation we choose as long as it's one of these two top ones up here. And almost just, well, you know, I maybe even after some analysis, I'd say, well, look, if I replace the y here, it's still going to require some distribution. Whereas if I replace this y here, even though there is distribution, at least I'm not working with a fraction at that point, and well, too much anyways. So I'm going to choose to use the bottom one in order to find the corresponding x value with this y value. So I got 6 groups of x and 3 equals 3y. But again, I'm going to replace the y value with the y value I think it is, which right now is showing as 87/20. So yeah, we get a lot of fractions on this, and I'll put this in my calculator, 3 groups of 87/20. And my calculator, when I did that, it gave me 261/20, like this. Now it should be equal to this other stuff, and we can go ahead and distribute the 6, which is fine. That'll give us 6x, and 6 groups of 3 is positive 18 right there. So next up, we need to subtract 18 from both sides. Maybe that'll make that fraction look just a tiny bit better at least. So now I got 6x, which I dropped here, and this zeroes out, equals 261/20 minus 18 in my calculator gives me negative 99/20. So it's still, I don't know, still doesn't look too pretty, but maybe a little bit better. It's negative 99/20. Well, the last thing we got to do on this is divide both sides by 6. And again, I would just use calculator to do this to make that coefficient 1. And I get x equals negative 99/20 divided by 6, which is negative 33/40. So we have the two answers right there. That's a 40 right there. But like I said before, we've got we should check. Okay, so I use the bottom equation to solve for the x. We use both to solve for the y. Let's use the top one because we didn't use it to solve for the other variable, in this case the x, in order to confirm truthfulness on this case. So I got 5 groups of 6x and y equals negative 3. That's good. And I'm going to replace the x and y values with their corresponding values that we found. And all I'm going to do from here is type this into the calculator, and again, we're checking for truthfulness here. So I just want to make sure that these are actually equal to each other, right? So on the one side, this is just equal to negative 3. So whatever after I type all of this stuff into my calculator, I should get negative 3. Let's find out. And yeah, my calculator spit out negative 3 as well, which means it's a true statement. Then I know that my two answers were correct. X is negative 33/40, and y equals 87/20. And yes, I mean, you know, sometimes the homework will ask for this as an ordered pair, right? So you could say negative 33/40 and 87/20, like this. So, you know, depending on how it asks for it, but the way we have it boxed in works as well. All right, guys, that's how you would do this one. Thanks for watching. I hope it helped you guys out. We'll see you in the next video.